Hello and thank you for joining me for today's lesson on kinetic energy. So we've talked about potential energy prior, which is energy of position, whether that's your stretch and your elastic potential or if your height above ground gravitational potential. Today we're talking kinetic energy. And kinetic energy is the energy of or energy due to motion. And so kinetic energy is the energy of an object due to its motion. That's going to be really important that we are aware of and understand. So anytime an object is being moved or an object begins to move, it has the ability to do work, and that's this kinetic energy. So this kinetic energy depends on two things. One, it depends on the object's mass. Bigger objects moving have more kinetic energy than smaller objects moving at the same speed. For example, a bowling ball can do more work than a table tennis ball when moving at the same speed. So you have a bigger bowling ball, you have a smaller table tennis ball or ping pong ball. Obviously, the bowling ball can do more damage, do more work. On the other side of this, kinetic energy is dependent on the square of the object's speed. So an apple falling at 10 meters per second can do more work than an apple falling at 1 meter per second. And this is important because this is actually going to be a large difference here. And so your equation that we're going to use that you need to be aware of is kinetic energy is equal to 1/2 times mass times velocity squared. So 1/2 mv squared is going to be our equation that we are going to use in this section. Okay, so because we're talking energy still, we're still expressed in joules. But notice how a small speed increase can cause a large increase in kinetic energy. For example, I have kinetic energy on the left, I have speed on the right. This individual has a mass that stays constant. So in this case, if I have a velocity or speed of 2 meters per second, this person has a kinetic energy of 100 joules. Okay. When they double that speed, they get up to 4 meters per second. Look at their kinetic energy is now up to 400 joules. So if we double the velocity, so velocity is doubled, kinetic energy increases 4 times. And that's because of this little squared. That's really important, and that's really big. That's what we're going to talk about and practice with today. Okay? And so kinetic energy depends more on speed than mass. So speed is more important than mass. In a car accident, we're more dangerous at high speeds above the speed limit, than low speeds or speeds at the speed limit. This is because with that equation, speed is squared. This is where all that damage comes from. So a small change in speed will cause a large change in kinetic energy, which can result in much more damage. Our atoms and molecules, we've talked previously, have kinetic energy as well. They're always moving, meaning they have kinetic energy because it's energy of motion. And we measure that with temperature, which we talked about previously, but temperature is the average kinetic energy of all the particles in a substance, just to take you back to first semester a little bit and review that. All right, let's do some calculations. So first question says, what is the kinetic energy of a 44 kilogram cheetah running at 31 meters per second? So some things I need to be aware of. One, I have an equation that I need to use, which is kinetic energy equals 1/2 mv squared. So some things that I can potentially know or need to know. I have Ke, I have mass, and I have velocity. And I'm going to solve this equation for which one of those I'm looking for. In this case, I know the mass is 44 kilograms. And I know that my velocity is 31 meters per second. So I'm solving for my kinetic energy, which is how this equation is set up. So I can just write it out as is. So Ke equals 1/2 times 44 kilograms times 31 meters per second squared. If I plug that into my calculator, 44 times 0.5 times 31 squared, you might have to be careful on 31 squared using parentheses. My kinetic energy comes to 21,142. And my unit for energy is always joules. Now I have 2 sig figs here and I have 2 sig figs here, so I can make this either 21,000 joules or I can call it 21 kilojoules. Remember, kilo means 1,000. So either one of these answers will work in this example. Question number 2 says a 35 kilogram child has 190 joules of kinetic energy after he slid down a hill. What is their speed at the bottom of the hill? So now, some things I know, or can know. So kinetic energy, mass, and velocity. In this case, it tells me I have 190 joules of kinetic energy. So I'm put my 190 here. It says that I have a 35 kilogram child. I know that 35 kilograms measures mass. So this is going to be 35 kilograms. And then I'm looking for my velocity. Okay, so the equation we've used is Ke equals 1/2 times m times v squared. So now we have to get v by itself. So I move some things. So first thing I'm going to do is I'm going to take everything times 2 because this is 1/2. So I'm going to multiply this side times 2 or divide it by 1/2 and this side times 2. So I get 2Ke equals mv squared. Now to get m out of the way, I'm going to divide it on both sides. So I'm down to 2Ke over m equals v squared. And then to get rid of that squared, I'm going to take the square root of both sides. So my velocity is going to be equal to the square root of 2Ke divided by mass. I'm going to plug numbers in. So I get the square root of 2 times 190 divided by 35. And make sure you do all of this here before you square root it. So take 2 times 190 divided by 35. And that should give you 10.85. And then if you square root that answer, you get a final velocity of 3.295. And because I need 2 significant figures, I'm going to do 3.3 meters per second. And because it's velocity, it just asks for speed, so I don't need a direction here. So 3.3 meters per second is my answer there. All right. I'm going to give you a chance to practice. So I will say these questions, then I'll pause it, and I'll give you the answers. So first, calculate the kinetic energy in joules of a 1,500 kilogram car that is moving at a speed of 11.67 meters per second. So you're looking for kinetic energy there. And the second one, a bowling ball traveling at 2 meters per second has 16 joules of kinetic energy. What is the mass of the bowling ball in kilograms? So think about what you're solving for and solve that one. Go ahead and pause your screens, work through those, and I'll give you your answers on the next slide. All right, here's your answer. For the first one, we had 102,100 joules, or 102.1 kilojoules could be our answer there. And our bowling ball has a mass of 8 kilograms. All right, some final questions to close things up. First question, what is kinetic energy? You should be able to define kinetic energy. I also want to know what my equation is. And then last one, what happens to my kinetic energy of an object if its mass doubles? What will happen to the kinetic energy if the mass doubles? Second question, what if the velocity doubles? What happens to my kinetic energy? Try to answer those, and I will see you next time.